Hi, today we are going to discuss how can we solve paper 1 or paper 2 multiple choice questions and paper 4 which is extended questions and paper 6 that is alternative to the practical of the IGCSE chemistry paper which is 0620 Cambridge paper. First, let me share the question paper with you. Give me a minute. Let me just get the question paper. Yes, here we are. So this is the, we are taking a sample paper that is March 2018. That is the India CG's paper. Paper 2, that is an extended paper. You're taking the question, say, let us think of question number 1. Question says, hydrogen chloride gas, HCl, reacts with the ammonia gas to form solid ammonium chloride. The apparatus is set up as shown. After a few minutes, solid ammonium chloride forms where the two gases meet. So it is clearly explained the sources of hydrogen chloride. You can see hydrogen chloride is taken in a cotton wool and it is set from the left side. That is, hydrogen chloride gas comes from there, and ammonia similarly comes from the other side, and they diffuse as they move and they react to form ammonium chloride. You can see ammonium chloride is formed, NH4Cl. When they react, they meet. All right, the question continues. If the experiment was repeated using hydrogen bromide in place of hydrogen chloride, how far along the tube does the solid ammonium bromide form? You just need to know where this, the new ammonium bromide formation would be ammonium bromide, NH4Br. Will it be this side or it will be on the same area, that is B, then C, that is on the other to the right side, or D. That's what they want you to say. Let us see how we will figure it out. Your answer should be one of them. So hydrogen bromide is here, and so the difference is between hydrogen bromide and hydrogen chloride. So when you look at hydrogen chloride, you know that is basically the difference is in its density or the molecular mass, we should say. Calculate the molecular mass. Hydrogen is 1 plus 35.5. So you have 36.5 is the molecular mass of HCl. Whereas in HBr, H is 1 plus bromine is 80. So it is 81. It clearly shows HBr is much heavier. As a result, being it is heavier, the movement of HBr will be slower compared to the movement of HCl. Heavier molecules diffuse slower. So it won't diffuse as fast as HCl, so it will travel only a shorter distance. So at the point, you know, where at the point A, ammonia will meet up with it. So it will form ammonia gas plus HBr, and you get ammonium bromide. Ammonium bromide. So the correct answer is A. Let us have a look in the mass scheme. Yes, it says the first one, answer is A. So that's correct. All right, now let us discuss the second one, second question. Let me clear it out. Question number 2 says, substance L melts at -7 degrees Celsius. All right, -7 is the melting point, into a brown liquid at room temperature. We have, in IGCSE syllabus, we don't have any brown liquid as formed at the room temperature this way. We don't come across any of those brown liquid. So sometimes it may not be familiar. That's not the point here. Let us just check. Which temperature is the boiling point of pure L? So it clearly says that -7 degrees Celsius is the melting point. So the boiling point should be above. Boiling point is above. So below that is it's a solid, right? And above that it's a liquid. Above the melting point it's a liquid. So the temperatures like minus 20 etc. it is a solid, and anything up to 0 degrees Celsius you can see, and 10 degrees Celsius all it's a range of liquid. Now out of this minus 77, can it be? No, because it is coming in the lower, you know, the other range below minus 7, so it cannot be a boiling point. Boiling point should be above minus 7. Can it be between minus 7 and 7? You know, it is not a boiling point is a fixed temperature. It is not a range. It's a pure substance. You know, substance, when they say in chemistry, substance, when they say, it means it's pure, right? So it cannot be B, and from that point, it cannot be D as well, because those two are ranges. The only option with us is C. C should be the correct answer. Check the mass scheme. C is the correct answer. Yeah, here we go. So that's all from multiple choices. Now let us move on to the extended paper. Let us say paper 4. Let us take that is an extended paper, theory paper 4, and I'm taking from again from the time zone 2. That's why it is 6062042. Let us discuss some questions. How do we answer that? In IGCSE, you have 1 minute for a question having the weightage 1 mark. So 1 minute, 1 mark. That is the idea in IGCSE. That is what is the expected time management for. In here, paper 4, when we look, this question is about gases. So all of them are gases. Yeah. The following substances are gases at room temperature. They say it again. Sulfur dioxide. Yeah, very familiar gases. AR, argon, noble gas. Carbon monoxide. Yeah, the famous poisonous carbon monoxide. Chlorine, the bleaching gas. Ammonia, the only alkaline gas. The only alkaline gas you have. And carbon dioxide is an acidic gas. You know, when we read about these gases, probably you have something in your mind. The last two are hydrocarbons. Yeah, just keep that in mind. Then identify by letter. You're supposed to write letter. They don't even mind even if you write the correct answer by formula, but they're expecting you to write the letter A, B, C, D for that. A gas which combines with the water to form an acid rain. There are two gases which combine with water to form acidic acids, which are these two. Both of them are acidic gases, right? But for making acid rain, carbon dioxide will never make acid rain. Acid rain, in our syllabus, we have studied, it is sulfur dioxide and nitrogen dioxide. You know, these two are making acid rain. So your answer is sulfur dioxide, so the answer is A. Two gases which exist as diatomic molecules, So which two gas? Diatomic means, the word meaning is two atoms, right? So out of that, this has 3 atoms in one molecule. This has 1, and this has 2. This has 2 as well, and this has 4, 3, 5, 11. So obviously, it's very clear, it is C and D. C and D. For here, each letter or each answer, you have 1 mark. Yeah, that is how you should answer that question. Okay, after that, the next question is, a gas which bleaches damp litmus paper. Whenever we talk about chlorine, halogens, we discuss that they have bleaching power, they are bleaching agents because of their oxidizing action. So chlorine matches very well, and if you have bromine or iodine, that also will be a good choice, you know, but in here it's chlorine, so your answer should be D. A gas which is used as an inert atmosphere in the lamp. Remember, argon is used as, that is one of the uses we talk about argon. as an inert atmosphere. It's an inert gas. Inert gas is no more, we are using the term is outdated. We use noble gases, okay? Two gases, so we need to answer that, it's B. And then two gases which are found in clean, dry air. Sulfur dioxide, no, it's in polluted air. AR, yes. Carbon monoxide, no, it's not in clean air. Chlorine, never. Ammonia, no. Carbon dioxide, yes. These two are no. So it is B and F. Yeah, that is how, you know, with the, you have some time for this. Yeah, it's again 2 marks, it's 1 mark each. Two gases which are found in refinery gas. Refinery gas, again, it's a petroleum fraction. So obviously you don't have to think much. It is these two, refinery gas. It is G and H. G and H. Let me tell you, refinery gas, it is the first component or the fraction with the lowest boiling point, which is mainly, it has the lower boiling, it is the lowest boiling fraction, and it consists of the fractions up to propane or maybe some amount of butane also, methane, ethane, propane, and some amount of butane as well. Okay, so it is methane and propane. So that is how you answer that question. There you get easy 2, 4, 6, 8, 9 marks. 9 minutes you have basically. Now let us see the next one. NF3 has covalent bonds. What is a covalent bond? It's a 2-mark question. So obviously if it is 2 marks, it has 2 valid marking points, you know. Mass scheme will have 2 scoring points. Covalent bond is the shared, a chemical bond formed by the shared pair of electrons. Shared pair of electrons. So you say it's a bond formed between non-metals due to the shared pair of electrons between them, you know. So for example, if you have Cl and Cl, it has a shared pair of electrons. This is a covalent bond. So covalent bond, actually it is a force of attraction between 2 bonded atoms due to a shared pair of electrons in it. So this is what you get 2 marks for. Let us just see the mass scheme for that. This is the mass scheme. Mass scheme says mark 1 for shared electrons, and next is pair of electrons. So if you write, you know, it's a bond formed due to because of the shared pair of electrons between atoms of 2 non-metals, you get the mark. All right. Now, so that is a covalent bond. If it was an ionic bond, how do you define it? Ionic bond is, if that's a force of attraction existing between positive and negative ions in an ionic lattice, and these ions are formed by the transfer of electrons from metal to non-metal. So that should have been transfer of electrons from metal to non-metal. In there, you have next one, a 3-mark question. Complete the dot and cross diagram to show the electron arrangement of a molecule of NF3. It's a covalent compound, NF3, nitrogen, fluorine, both are non-metals. Show outer electrons only. Okay, let me take nitrogen. Nitrogen has, if I'm doing, probably you remember, this is the single bond. It's already represented. So 1 electron from nitrogen, 2nd electron, 3rd electron from nitrogen. Nitrogen has 5 electrons in the valence shell. So the next 2 electrons I draw as a lone pair of electrons on nitrogen. Now next is fluorine. Fluorine has, if I used a cross for nitrogen, I should use dot for fluorine. Fluorine has 1 electron. Then the rest 6 electrons as lone pairs. Again, 1 electron there, 6 electrons outside because they are not used up. 1 electron there, 6 electrons outside. So that's a correct structure of NF3. Now, they're asking, I mean, they asked this for 3 marks. What are the marks for? These 3 bonded pairs of electrons will get 1 mark. This is the second mark. And, you know, having this 3 pairs, that's a third mark. So lone pairs, they give credit. Bonded pairs, they give credit. And the lone pairs are there on nitrogen as well as on fluorine. That is why you get these marks. I think that's it from paper 4. Now we will move on to paper 6 as well. Paper 6 is alternative to practical, and people do it for various reasons. Why do you choose paper 6? We have paper 5 and paper 6. Paper 5 is you conduct the practical, and you will have the questions based on the practical and observations you take, then conclusions you write, and more questions based on that you write, and draw the graphs and take the deductions and answer more questions. Planning question is a part of both paper 5 and paper 6. In paper 6, we don't have the practical to do, so they set up a paper in such a way that it looks like half of the practical report is incorporated. They give you the data, they give you the readings, and you just need to complete it and answer the questions. Sometimes you may have to do the calculations as well. Alternative to practical, and this year, by and large, I don't know, most of the schools are going to do alternative to practical because we are not sure how much or how many practicals we can do in the lab because of the special pandemic situations. Generally, the first question will be a question which is based on apparatus and the procedures, the simple procedures and apparatus. And here you can see it is all about our chromatography experiment. Yeah, it is continued, and its calculation as well. The second one will be a lengthy question. Usually that's an experiment, maybe a titration, maybe a redox titration or normal titration, acid-base titration, or maybe it's based on a rate experiment. Yeah. This time it seems that, or thermochemistry also can be. Here it's a reaction between hydrochloric acid and sodium carbonate solution. So what are they measuring? So the volumes are measured here. You can see both of them experiment. Both of them have the volumes measured, and methyl orange is used. Yeah, that's a titration. More questions on that. We are not going into that. Question 3, you can see that's a qualitative analysis. Qualitative analysis means it is the identification of the ions. Ions, positive anions and the cations are identified based on the solutions and experiments. Basically the cations, we use 2 solutions. One is sodium hydroxide, one is ammonium hydroxide. More details later. We are focusing on the planning experiment today. Planning experiments are many times, if you do a few years question for an exam preparation, I would recommend you to go over the past exams for a good understanding after your final revision. I never recommend that you should be preparing yourself through the past papers. Prepare yourself through your notes, through the teacher's notes, through the websites, etc. Various sources you can prepare yourself, and you should have some short notes made. And after preparing all that preparation, the final touch is you solve some past papers. That serves in different ways. That helps you in different ways. How? One is it gives a sense of timing. That's very important. Second one, it gives a good feel of that exam feel. You might have already written the mock exams. After that, you're writing more, so that the time management is an important factor there. IGCSE, we don't have, it is not a relaxed process. We have just enough time only, especially paper 4. Paper 4 is very tight. Paper 6, usually we have seen students get enough time. Paper 4, if you are not following up the pattern, you have like 75 minutes and you have 80 marks to write. Almost it is like 1 minute and 1 mark. And paper 6 also, like this kind of big questions, we always recommend 6 marks. 6 marks means 6 minutes or slightly even more than that, because you might have saved time from the other questions which are comparatively easier. Here, look at this. Magnesium reacts with the dilute sulfuric acid at room temperature to form hydrogen gas. Most likely, the opening sentence will give a strong clue of the procedure, what is happening during the reaction. It just tells us. Plan an experiment to find the rate of reaction between magnesium ribbon and dilute hydrochloric acid. Magnesium ribbon and dilute hydrochloric acid. We need to plan an experiment where we are going to find the rate of reaction between magnesium and hydrochloric acid. In your answer, include the diagram, indicate how you could use the results obtained to find the rate of reaction. It's a 6-mark question. If I draw the diagram, first the planning should be done in your mind. Whenever a question comes on rate, the first thing comes to your mind, because in your syllabus, they say student should know how to follow the rate of a reaction which involves the evolution of a gas. So gas is produced. So the methods are gas collection or mass loss, where you allow the gas to escape. Here it is hydrogen produced. So even after hydrogen is escaping, we don't get a mass reduction. Very negligible. So mass loss method is not appreciated here. Here more appreciated method is, and even otherwise most of the cases it will be the gas syringe method. So you draw a diagram which shows you have, I would suggest you have a container taken like a conical flask, then a gas syringe connected to that, then the conical flask should have a rubber bung. Close it. It should be airtight. Neatness is not a major thing, but if you can draw a neat diagram, it'll be really good. And inside you have, this is your gas syringe, the piston moving backward. This is the end of, where you when you draw a syringe, make sure you show the graduations without fail. All right, now here you take, that is the acid, and inside that you show the magnesium ribbon. One ribbon is quite good enough. Do the labeling without fail. Make sure you do the labeling. This is gas syringe. This one, hydrogen, that's a hydrogen gas. This is conical flask. This is, what acid is that? Sulfuric acid, H2SO4. This is magnesium ribbon, Mg ribbon, and that's a rubber bung, rubber cork. That's it. So now you need to have of course, the timing is very important when it is rate. Rate is finally, rate is equal to, at some point you are going to write volume of the hydrogen produced, volume of H2 produced over time taken. So you need to have the timer as well. So you say, take a known volume of sulfuric acid. The volume is not very necessary to say that, it has to be a known volume, a certain amount of sulfuric acid, dilute sulfuric acid. Then a piece of magnesium ribbon is taken. And, if you want to collect all the gas, the addition should be with a test tube. It is not necessary here. Connected to the gas syringe, add magnesium ribbon to dilute sulfuric acid taken in a conical flask. Make sure you say that. You know, it is not necessary to write all of this in sentence, but a well-labeled diagram can earn maximum marking scoring points. Yeah. So we need to say that start the experiment, set up the experiment as above, set up the experiment as above. Start the timer, start the reaction by adding the magnesium ribbon into the acid and start the timer. Start the timer. Measure the volume. Measure the volume of hydrogen at regular intervals. Then rate is equal to volume of hydrogen over time taken. Let us see the mass scheme and how many marks we scored for this. The mass scheme says, the mass scheme I have opened it already, magnesium added to sulfuric acid. It's very clear, and it is definitely needed that the mixing of reagents you need. In all the planning experiments, they always give credit for that. You need to say that, the reagents are mixed. Suitable container with the ability to have a bung. And here we said that is a conical flask. It cannot be a beaker because you cannot measure the hydrogen produced. You cannot measure, you cannot take the, collect it in any container if you are taking it in a beaker. So we should have a conical flask. Methods of measuring gas volume by gas syringe, we have done that. Here it is gas syringe, that's a third mark. Start timer or timing is mentioned. Yeah, that's a fourth mark. Measure the volume of gas, we said, that's a fifth mark. Then set the time till the end of the experiment or at regular intervals, we said, that's a sixth mark. It's an extra marking point, 7 marking points they have given. Any 5, any 6 will bring you complete full marks for this. Okay. On the other side, they have mentioned about the mass loss method. That's a desperate attempt, and I would suggest you should go by this. Okay, with more informations, we will see again with another paper. Okay, thank you for watching.